Today's topic is standard form quadratics. I can statement, graph quadratic functions in standard form using technology. By technology, we are talking about graphing calculators. You can come in before and after school and use one of our graphing calculators. You can rent one from the library for $20, or look online, there's free ones, or look for an app. But you will need to watch this video with a graphing calculator. Vocabulary. Standard form is an equation where y equals ax squared plus bx plus c. A, b, and c are numbers. We can use those values of a, b, and c to solve for certain key parts in standard form. Now, some of these things you can find by just looking at the equation. Other things you're going to have to do some math. Let's start with the easy stuff, the extrema. You can find the extrema, or min and max, by looking at the value a. If a is positive or if a is negative, it will tell you if you have a maximum or minimum. Now, it's kind of opposite of what you would think. If a is positive, my parabola is going to open up like this, meaning I have a minimum as the extrema. If a is negative, it's going to open down, giving me a maximum. So think kind of opposite. Positive will give you a minimum, negative will give you a maximum. Another very easy thing to find is the y-intercept. That's all based on the value c. C is the y-intercept, but make sure to write it as an ordered pair, 0, and whatever the value of c is. The next thing is the axis of symmetry, the line that cuts the parabola in half. It's going to be x equals, and it has a little equation, x equals negative b over 2a, where you take b, change its sign, so negative b over 2 times a. Now, if you started to notice from the last homework, the axis of symmetry goes through the vertex. Because it goes through it, they will share the same x value. So to find the x value of the vertex, you're going to do negative b over 2a. To find the y value, you're going to take whatever x would be and plug it back into the equation. We're going to practice this on the first example. Example 1, we're going to solve for the vertex, axis symmetry, extrema, and the y-intercept. You can do this in any order. I like to start with the easy stuff, the extrema. So for the extrema, I just need to look at the value of a. A is a negative 2, so remember it's opposite. If it's negative, we're going to have a maximum. Next, the y-intercept. That's just looking at the value c, so 0, negative 30. Now we need to do a little bit of solving. For the axis of symmetry, we need to use that little equation. X equals negative b over 2a. Let's plug in the values. B is 16, so negative b would be negative 16. Over 2 times a is negative 2. That takes me to negative 16 over negative 4. Negative 16 divided by negative 4. Carefully, negative divided by negative is going to make it a positive. So the axis symmetry is x equals positive 4. Now once you find the axis symmetry, you're halfway to finding the vertex. They share the same x value. So x equals 4 for the vertex. I just need to find the y value. I can do this by taking 4, plugging it back into the equation, and solving for y. So y equals negative 2, but instead of x squared, I'm going to plug in 4 squared. Plus 16, instead of x, I'm going to plug in 4 minus 30. Now I can do all the math and solve for y. Well, let's start. 4 squared is 16. 16 times 4 is 64, and minus 30. Well, negative 2 times 16 is going to be a negative 32, plus a 64, minus a 30. If you add those all together, you're going to get that y is going to equal 2. So now I have my extrema, y-intercept, axis symmetry, and vertex. Example 2, we're going to try it again. Pause the video and do any parts you think you can do on your own. I like to start with the easy stuff. So extrema. Now the value of a is hidden because it's in invisible 1. But it's a positive 1, so think of the opposite. It's going to give me a minimum. Y-intercept, just look for the value of c. So 0, 9. Axis of symmetry. See if you remember the equation. X equals negative b over 2a. B is 6, so when I plug it in, it's going to be negative 6 over 2 times a is 1. So negative 6 over 2. My axis of symmetry is negative 3. Now that's also the x value to the vertex. So plug in negative 3 for the x. To find the y value, I'm going to plug in negative 3 and solve for y. So y equals, instead of x squared, negative 3 squared, plus 6, instead of x, negative 3, plus 9. Well, negative 3 squared means negative 3 times negative 3, which is going to switch back to a positive 9. 6 times negative 3 is negative 18, plus 9. 9 minus 18 plus 9 gives me a vertex of 0. Okay, quick review of how to use the graphing calculators. Just a reminder, you can rent one from the library, use an online one, apps, or come in before and after school and use it. The graphing calculator, all the graphing buttons are these gray buttons at the top. You really only need to focus on 3 of them. The first button is the y equals, and that's where you plug in the equation. The last button is the graph, so that's where you can see a general look of the graph. And just as useful is the table above the graph. Now it says it in blue, so to get to that you push second, graph, and then it will show you the table. So example 3, we are going to graph this equation as well as solve for those 4 things. Let's do the solving first. If you can do it on your own, try it on your own. Extrema. Visible 1, it's a positive, so that means I have a minimum. Y-intercept. C is 7, so 0, 7. Axis of symmetry. X equals negative b over 2a. Well, b is 6, so it's going to be negative 6 over 2 times 1. That gives me an axis symmetry of x equals negative 3. Vertex. We already have half of it. To find the y value, you need to plug in. So y equals negative 3 squared plus 6 times negative 3 plus 7. Negative 3 squared is going to be positive 9. Negative 18 plus 7. So 9 minus 18 gives me a negative 9 plus 7, giving me negative 2. Let's start graphing by plotting the points we do know. I'm going to start with a vertex. The vertex is -3, -2, which means my axis symmetry goes right down it. Now the axis of symmetry cuts my parabola in half, which means every point on the right side of the parabola has a matching point on the left side. This becomes very useful because if I plot one point, such as the y-intercept is 0, 7, I can plot its symmetrical point on the other side. Now, y7, no, the y-intercept is 1, 2, 3 values to the right of the axis symmetry. So I'm going to count the exact same over to the other side. 1, 2, 3, and I can put another symmetrical dot. Now to graph accurately, you always want to have 5 points. Well, we have 3 points. To find any extra points you need, you can plug this equation into the graphing calculator, graph it, see if your graph's matching up, and go to the table to find additional points. Now if I go to my table, I can see that it also has point at -2, 1. Nope, -2, -1. So it has its symmetrical point at 4, -1. Now you only do need 5 points, however you can plot even more points. I also have a point at -1, 2, and a symmetrical point at -5, 2. The more points you plot, the easier it is to draw the U shape. So you want to try to do gentle curves, going down and back up, creating a U. Arrows at the end. Example 4, we're going to try it again. Try all the parts you can do on your own, and watch the video for the parts you don't remember how to do. Extrema, A is a -2, so think opposite, it's negative, so we're going to have a maximum. Y-intercept, that's just C, 0, -8. Axis of symmetry, we're going to use that little equation, x equals -b over 2a. B is 8, so it's going to be -8 over 2 times -2. So that's -8 over -4. That gives me an axis symmetry of 2. And last, vertex. The vertex and axis symmetry have the same x value. You only have to find the y value. So let's do some plugging in. Y equals -2. Instead of x squared, we're going to plug in 2 squared plus 8 times 2 minus 8. Well, 2 squared is 4. -2 times 4 is -8. 8 times 2 is going to give me 16 minus 8. Well, -8 plus 16 minus 8 gives me a y value of 0. So let's start plugging in some numbers. I like to start my vertex, 2, 0. My axis symmetry is that line that goes down the middle. So my y-intercept is at -8, and its symmetrical point would be on the other side of the axis symmetry. This one's to the left, so I'm going to go to the right and put its matching point. Now I still need a few more points to graph this. I can do that by using my graphing calculator. Go to y equals, type in the equation, go to graph, check it out, and then go second graph to see the table. Plot as many points as you need to make a nice looking parabola. I'm going to be plotting the point 3, negative 2. And once I have one point, I have its symmetrical point. And since I have 5 points, I can draw my gentle curved U. Arrows at the end. So, can you find the key parts of a parabola in standard form? Can you graph a parabola in standard form using technology? If you need help, watch the additional resources. Come in for more help if you need to.